Okay, page 3 and 4 of trigonometric functions. Um, Consider the function at right. Right here the vector which represents a translation of c horizontally and d vertically. Okay, we haven't done vectors yet, so maybe you've seen them before, but basically vectors are like matrices or, like tables. And in this case, what they want is they want a vertical matrix here with C in the top and D in the bottom. So C is the amount that you're shifting the sine wave to the right, and D is the amount that you're shifting the sine wave up. Okay, so that's all they want here, and I know you haven't seen this before, but after we use it a few times, you'll see that they're not demanding that much from you yet. Okay, what is the period of the function? Okay, the period of the function, remember, we can find by saying, hey, bx equals 2 pi. Okay, and then so let's see, what's x going to be? X is equal to 2 pi over b. Okay, so the period is 2 pi over b. So you can see the bigger the b gets, the smaller the period gets. Sketch the graphs of the following for x between 0 and 4 pi. Okay, so first we're just going to draw, we're going to label the axis first. So this is 0, and this is 0, and this is, let's see, pi, and this is 2 pi. Okay? And then so first we're going to do, first we'll just do a regular sine wave. So a regular sine wave looks like this. Kind of like that. Okay. Now we're going to do 1a here. So sine of x minus 2. And when they say sine of x minus 2, first you do sine of x, and then you subtract 2. Okay, so actually this is the d that's being made 2 here. So if d is negative 2, that means that we're moving the sine wave down 2 positions. Okay, so like for example, that would be, let's see, if this is negative 1, this would be negative 2, so we're actually moving it all the way down to here. And so it would look kind of like this. Okay, next one we'll do in pink. Y equals sine of x plus 2. So if it's x plus 2, if we look at this, then c is actually equal to negative 2, right? And if c is negative 2, that means it's moved 2 units to the left. So 2 units to the left. Let's see, one of these, this is actually 6.28. This is equal to 3.14, and we're moving it to the left. So let's see, moving it to left 2, it would be about here, right? Maybe about here. And then this point would be about here or so. So it's kind of hard to draw because we don't know exactly where these lines are, but it would kind of look like that. Okay? And now let's do x plus pi over 4. So instead of moving over 2 units to the left, now it's moving pi over 4 units to the left. Pi over 4 is a little bit easier because our scale on the y-axis is written in pi here. So pi over 4 would be like that much, right? So everything would be moved over 1/4, like that. So it would be, so kind of like that, right? Kind of like that. Okay, so that's the green one. All right, 2. State the period of y equals sine 5 over t. Okay, now remember, to find the period, we could say, hey, what's inside the sine needs to go from 0 to 2 pi. So when is this equal to 2 pi? It's equal to 2 pi when t is equal to 2 pi divided by 5, 2/5 pi. Okay? So that is the period for A. And the period for C, you would do the same thing. You would say negative 2t is equal to 2 pi. So t is equal to 2 divided by negative 2, which is negative 1. So the period is negative pi. And you could just change that to pi, positive pi, because period can't be negative. Okay. Number 3, find b in y equals sine bx if b is greater than 0 and the period is 3 pi or 50. So we'll do, so we'll say bx is equal to 3 pi. Oh, I'm sorry, that's not right. Bx equals 2 pi. Okay. And x is 3 pi. So we have b times 3 pi equals 2 pi. So what's b equal to? b is equal to 2 pi divided by 3 pi, which is 2/3. Okay? And here we're going to do the same thing. bx equals 2 pi. Okay? And then x is 50. So we'll have b times 50 equals 2 pi. b is equal to 2 divided by 50 times pi. Okay. All right. Number 4. State the transformations which map y equals sine of x onto y equals sine of x minus 1. Okay, so this would be, so we could express this one as, remember we used matrices before, or vectors to show the translation. So this translation would be 0 in the x direction and -1 in the y direction. Okay. Now what about c? Now sine x becomes y equals 2 times sine x. So that's saying that the a factor becomes, now remember the a factor, it's right there. So the a factor becomes 2, so that means it's a vertical stretch by 2. Okay? And then for this one, it would be a vertical stretch, or it would be shrinking actually, by 1/2. Okay, and then this one, sine x turns into negative sine x. You're just kind of flipping it over. So like, for example, this sine wave becomes this one. Okay, so that would just be like what they call a reflection about the x-axis. Okay, and then finally, this one, we have two translations happening. One is that a equals 2, and the other is that b equals 3. So a equals 2 would be a vertical stretch by a factor of 2. And then b would be a horizontal stretch by a factor of 1/3, right? Because a 3 actually makes it shrink. Okay. All right. Moving on to page 4. Below is a table which shows the mean monthly maximum temperatures for a city in Greece. Use a sine function of the form t equals a sine b times t minus c plus d to model the data. Find good estimates of the constants a, b, and c, and d without using technology. Use January is 1, February is 2, etc. So we'll make these into numbers, which is important so that we can actually make a graph of this. Okay. All right. There we have 1 through 12. Now we're going to try to write a sine function so that it would follow this data, and then we're going to take our calculator and see if we can model this data successfully. Okay. So let's see. You remember how to figure out A and D? We did a couple chapters ago. So, or not chapters ago, but subsections ago. So remember that A and D are kind of determined by the max and the min. So can we find a maximum and minimum here? Let's find the maximum. We'll make it green. The maximum looks like it's 27, right? What about the minimum? We'll make it red. Minimum looks like it's 14. So now that we know the maximum and minimum of this curve, which we're assuming is a sine wave, then that means that we can find the d value, right? The d value would be the average of the minimum and maximum. So the average of those, we would just add those two together, 14 plus 27. We'll do that on the offline calculator. 14 plus 27, and we get 41 divided by 2, and then we discover that d should be 20.5 because that's the average of 14 and 27. Now to find the amplitude, what we do is we find the average of we find the average of 14 and we find the difference of 27 with 20.5. Okay. The other way we could do it is we could subtract 27 minus 14, and we get 13, and we divide that by 2, 6.5. So the amplitude is actually 6.5. The other way we could get 6.5 is we could take 27 minus 20.5, that gives us 6.5. or we do 20.5 minus 14, and that also gives us 6.5. So you can see that the amplitude is equal to half the difference between the max and the min. Okay, and then the only other thing that we need to do is we need to figure out the b value. Okay, so the b value is related to the period, right? And the period is related to the time it takes to go from the min to the max, right? So let's draw a sine wave. Okay, it looks kind of like this, and one period is like this far, right? So how many periods does it take to go from the min to the max? This is the max, this is the min. It looks like half a period to me. Okay, so if we measure the time between the max and the min, we can see that it is 5 months. So half a period would be 5 months. The whole period would be 10 months. So if we know our period is 10 months, we can use the equation bx equals 2 pi, and then we could put that x is 10, b is unknown, and then that's equal to 2 pi. So b is actually equal to pi over 5. Okay, so we'll put that pi over 5 for b. Okay, and then last of all, we need to figure out what negative c is. Negative c is the amount that the sine wave has been shifted. And the way you can tell how much the sine wave has been shifted is by taking the point that typically is at 0, which would be, let's see, that would be like halfway in between the 14 and the 27, so like right here. Okay, so this is a 0 point, and this point would typically be at time equals 0, and right now it's at time equals 4.5, right? It's at 4.5. So actually we can see that the sine wave has been shifted from time equals 0 right to the right to 4.5. Okay, so since it's been shifted over by 4.5, then c is probably something like 4.5, right? Except it's going to be, it's t minus 4.5, but actually the c value is 4.5, right? So now I think we have pretty much everything. And now we're going to put in these data points in the calculator, and then we are going to put in the formula and see how well we've done. Okay, so we'll do stat, and then we'll go into edit, and then we'll clear the values that are here because we don't need these anymore. Clear, yeah, and then we go down, and then we go down to L1, and we do the same thing. We clear, and then we go down, and then we just start typing in the numbers. We're going to put the numbers 1 through 12, right? And I'm not going to make you watch me do that because that's really boring. Okay, you see in the L1 column, I typed in the x values 1 through 12. In the L2 column, I've typed in the temperature values, starting with 15, 14, 15, going all the way to 16. And then I'm going to graph these, and I've already set up stat plot so that it's going to graph it. And I don't see anything, so I'm going to do zoom, and then I'm going to go to zoom stat. Hopefully we'll see something now. Ah, there we go. Okay, so yeah, it looks like a sine wave. And now we're going to go to y equals, and we're going to put in the function that we invented here. We're going to put 6.5, because it looked like it was about an amplitude of 6.5. And then we're going to multiply that times a sine. And then we're going to put in there pi divided by 5, second pi divided by 5. And I should put that in parentheses because I want to divide the pi. Pi divided by 5. Okay, and then multiply that times x minus 4.5. So x minus 4.5. And then we add 20.5. 20.5. One thing you definitely have to do is you need to go into mode and you need to change to radians, okay? Because when I first did this, I was in degrees and I got something really weird. It's got to be radians because we are making this equation in radians. Then when you graph it, you can see that, wow, here are my data points, and then look at that curve that I predicted. That is a pretty good prediction there. It's very close, right? Okay, so we're going to do a couple more examples because this is not something you're going to be able to do overnight. Okay, so here we're trying to make the model again, a model again. So we have, now we have temperatures in Antarctica. And we're just going to replace the month names with numbers like we did before. Okay, and then it says to use a sine model for this data without using technology. Okay, let's see. So we're going to do the same thing we did last time. We're going to mark the minimum temperature with red, so negative 19 looks like. And then we're going to mark the maximum temperature with green. Looks like it's 0. And then so we can use the maximum and the min to find several values that are important. Let's see, b times x minus c plus d. Okay, so we can use the maximum and min to find a and d. To find d, what we do is we find the average between the maximum and the min, because that's the value of the principal axis. So that would be 0 plus negative 19 is negative 19 divided by 2, which would make it the average. It would be negative 9.5. So plus d would actually be plus negative 19.5. And a would be the difference between the maximum and the minimum divided by 2. So we'll do 0 minus a negative 19, which would be 19, divided by 2 is 9.5. So this would be 9.5. Okay, so we have 2 of the numbers so far. Let's see, then let's try to figure out the b value. So the period here looks like it's about, let's see, from 1.5 to 8. Okay, so the difference between 1.5 and 8 is about, or 8 minus 1.5 is about 6.5. And that's about double or half the period. So 6.5 times 2 gives 13. So like the whole period would be about 13 months. Okay, so the whole period is 13 months. So if we have the equation bx equals 2 pi, then x is 13, and 13 times b equals 2 pi. So what would b be? B would be 2 pi divided by 13. So here for b, we're going to put 2 pi divided by 13. Now I just noticed that I made an error here for plus d, right? Because plus d is calculated by taking the maximum and the minimum and averaging them. So 0 minus 19 is negative 19, divided by 2 would be negative 9.5, not 19.5. So I just need to erase that there. Okay? All right, now let's figure out c, which is kind of the toughest one to find out. Okay, so the way we calculate c is when you have a sine wave, the 0 point is right here. Okay? But another way to identify the 0 point is that you could take the maximum, you could take a minimum, let me color it red, you could take a minimum and then you could take the following maximum and then you could find the point which is exactly in between the two by averaging them. Okay, so let's try to do that. Okay, now here's a minimum. Now let's find the following maximum. The following maximum would be half a cycle later. So since the cycle here is from 1.5 to 8, that means that the cycle is about 6.5. So it would be at about 14.5. So at month 14.5, there would be a green point here, right? Okay, so let's take 14.5, and then we'll subtract, or we'll add 8. And then we'll get 22.5. And then we divide it by 2, and we'll get 11.25. So the midpoint between these two is 11.25. Okay? And 11.25 is the beginning of the sine wave. So we'll put, for C, we'll put 11.25. Okay? All right. And that is the answer here. Okay, so the formula is the equation is 9.5 is A, 2 pi over 13 is B, C is 11.25, and D is negative 9.5. Okay. Some of the largest tides in the world are observed in Canada's Bay of Fundy. The difference between high and low tides is 14 meters, and the average time difference between high tides is about 12.4 hours. Okay, so let's look at a sine wave here. High tides are at the peak. So they're saying the difference between two high tides is 12.4 hours. Guess what? That is a period because this is a full cycle, right? This is a full cycle of the sine wave here. So they're saying that's 12.4 wide. That's the period. Okay. What other information do we know? The difference between high and low tides is 14 meters. So this is 14 meters. So what is the amplitude? The amplitude is half that, right? Because the amplitude goes from the middle to the max or from middle to the min. So that would be 7. Okay? So A would be 7. T would be 12.4. Well, what else do we know? Find a sine model for the height of the tide h in terms of time t. So let's see. That would be h equals a sine of b t minus c plus d. Okay, and so we know that a is 7, right? Because we already found that. And we know that the period is 12.4. So bx equals 2 pi. The period is 12.4, so 12.4 times b equals 2 pi. B is equal to 2 pi divided by 12.4. Okay, so we can put that here in b. We could put 2 pi over 12.4. And then in C, we can't really figure out because they didn't give us that information. So it's 7 sine 2 pi over 12.4 times t minus c, and plus d. We can't figure out plus d either because d is d depends on like some relative tide height, and they never told us that. So we don't know D, we don't know C, so we're left with that, okay? So basically, let's see, the period is 12.4, right? So let's count, we'll say 0, 2, 4, 6, 8, 10, 12. 12.4 would be about to here, okay? So this would be 12, this would be 0. And the height of the amplitude is 7, and this would be negative 7, and this would be 0. And let's see, halfway would be about here, so the sine wave would kind of go like that. Okay, so we've taken into account the 7, we've taken into account the period, and C and D, this could be shifted up or down, it could be shifted left or right, but we don't really know that. Okay, so we basically have A equals 7, and we have B equals that. And C and D, we don't know. Okay?